All right, so today we are going to discuss defining and implementing a test plan. This is another course in our Integrate Testing into Your Development Flow. In the previous presentation, I discussed how to create a test strategy, which those kind of go hand in hand, where a test strategy is an overall view of your testing process, and the test plan gets into more individual components. So today's agenda, we're going to talk about what is a test plan, briefly review what a test plan is versus a test strategy. We're going to cover the different types of a test plan, the components of a test plan, look at some sample test plan templates at the end of this presentation, and then we're going to discuss some tips on writing the successful test plan. So what is a test plan? Well, the definition, as the International Software Testing Qualification Board defines it, is a document describing the scope, approach, resources, and schedule of intended test activities. It identifies, amongst other test items, the features to be tested, the testing tasks, who will do each task, the degree of tester independence, the test environment, the test design techniques, and entry and exit criteria to be used, and the rationale for their choice and any risks required in contingency planning. In a sense, it is a record of the testing planning process. So I kind of highlighted some of those here. So it identifies the features to be tested, testing tasks, rationale for choices. And we're going to get into each of the individual components of this in a minute. Before we get into that, I decided to throw in a little Dilbert cartoon here. So why we need a test plan? And here's Dilbert talking to his pointy-haired boss. I'd like to thank all the people who helped design the technology test parameters. Thanks to your input, the test had nothing in common with how things work in the real world. So I wasted 2 weeks of my life only on a test that is not only meaningless, but also dangerously misleading. The slide shows the gap between the test results and reality, Earth and the moon. The pointy-haired boss, we hear this all the time. We'll use the test results anyway because it's the only data we have. Dilbert, fine. I hope you all choke to death on your lunches. Pointy-haired boss, why is he so cranky and something about data? We see this time and time again in many companies where the perception of what needs to be tested is not really what needs to be tested, or what we're told to test really does not apply to what is actually being tested. So there can be a lot of confusion and a lot of misleading data about the results of how a test is done, if the product was actually tested, and if it was tested correctly. So to quickly review, what is the difference between a test plan and a test strategy? Well, essentially, a test plan deals with test coverage, features to be tested, features not to be tested, estimation, scheduling, and resource management, whereas a test strategy defines guidelines for the test approach to be followed in order to achieve the test objectives and execution of test types defined in the testing plan. Like the test objectives, approach, test environments, automation strategy and tools, and risk analysis with the contingency plan. So test plans essentially can reside in a test strategy, and the test strategy is the overall approach to everything that you're going to be testing. Types of test plans? Well, there are generally a couple different types of test plans. Typically, you have your master test plan, which addresses multiple test levels. And then you have what is known as a phase plan, which is a test plan that typically addresses one test phase, but also adheres to the guidelines set by the master plan. These plans can consist of different levels and types, depending upon the scope of the testing. Some examples are level-specific, which could be unit testing, integration testing, system testing, regression testing, and acceptance testing. Some other types of plans or type-specific test plans are compatibility test plans, GUI test plans, browsers and devices, performance test plans, security test plans, and synchronization test plans. So you can have a lot of different phases, and you can have different test plans for each phase. And then typically you would have a master test plan, which would incorporate all the different phases that are in the overall test plan. The components of a test plan that we're going to cover today, there's about 19 of them. You don't have to incorporate every single one of these into your test plan. If it fits, add it. If it doesn't really apply, leave it off. You really don't want to bloat the test plan with information that doesn't really apply. So we're going to start with the test plan identifier. We're going to then get into the introduction, the references, the test items, features to be tested, not to be tested, the different types of approaches you can take, items pass-fail criteria, when to suspend or resume a test flow, what are we trying to deliver, what are the test deliverables, different testing tasks, what do you want your users to actually test, or how do you want to task your users to test the software, different types of test environments, servers, mobile devices, things of that nature. We're going to look at how we should really define our time estimates, scheduling out the testing, staffs, responsibilities, risks, assumptions and dependencies, and the approvals. First, we're going to start talking about the test plan identifier. So the test plan identifier provides a unique identifier for the test plan itself, its level, and the level of software it's related to. So every deliverable has a unique identification number, which could be alpha or numeric, and is usually the same as the company's configuration management process, or CM, or software release numbers. The test plan identifier also includes the following. First, make sure to identify the plan level it represents. Is it a master plan or a phase plan? If it's a phase plan, make sure to identify which level it represents, such as a unit or performance test plan. Next, keep the naming of the test plan to a unique short name. This will make it easier to identify later. Also, make sure you always use correct versioning date and versioning numbers of the procedure. Otherwise, you will not be able to tie this document to the specific changes later. Also, don't forget to include who the version author is and their contact information. This will be crucial later in case there are any questions or discrepancies in the plan that need to be clarified or addressed. Finally, include the revision history of the document. This revision history identifiers should be changed to reflect the revisions to the document. Each revision history will also need to be added the identifier section or introduction. The introduction is where we state the purpose of the plan, possibly identifying the levels of the plan. For instance, is this a master plan or one of the many possible phase plans? Again, unit or performance. What is contained in the introductory section is essentially the executive summary part of the plan and is a brief overview about the project and objectives of the current release. For example, this product could be a new web service plugin tool, and the objective could be to create a new mobile application that interacts with this web service. Now, this does not just have to apply to new applications. It can also apply to existing products that may need a new feature, enhancement, or defect fix. It doesn't matter. Just make sure that you clearly specify the goals and objectives, as well as any additional constraints on the project. References. While not mandatory, it is a good idea to include a reference section that refers to other project-related items, plans, or documents which contain information relevant to the project. This section will contain a list of related documents with links to them if available, including the following: a project plan, quality assurance plan, configuration management plan, project specifications, business documents, related policies and standards, and for lower level plans, reference to their higher level plans. So if this is a phase plan, make sure you reference the master plan or any preceding parent plan that applies to this particular test plan. References could also include things like wikis or JIRA ticket numbers or type of project management systems. You could include links to those as well. Test item. The test item section contains things you intend to test within the scope of this test plan. Essentially a list of what is to be tested. This can be developed from the software application test objectives, as well as other sources of documentation and information such as requirement specifications, design specifications, user guidelines, operation manuals or guides, installation manuals or procedures. Now, as mentioned previously, this can also be controlled and defined by your local configuration management process, if you have one. This section will include version numbers, configuration requirements where needed. It may also include key delivery schedule issues for critical elements. Identify any critical steps required before testing can begin as well, such as how to obtain the required items. This section can be oriented to the level of the test plan. For higher levels, it may be by application or function area. For low levels, it may be by program, unit, module, or build. References to existing intended reports or enhancements requests should be included. This section can also indicate items that will be excluded from testing. Features to be tested. This is a listing of what is to be tested from the user's viewpoint of what the system does. This is not a technical description of the software, but a user's view of the functions. It is recommended to identify the test design specifications associated with each feature or set of features. Set the level of risk for each feature using a simple rating scale such as high, medium, and low, or HM&L for short abbreviations. These types of levels are understandable to the user. You should be prepared to discuss why a particular level was chosen. This is another way where the test objectives can be used to help identify the sets of objectives to be tested together, taking advantage of the hierarchy of test objectives. Just take a note, the rating system, if you use project management tools like Jira, you have things like critical, high, low, or you can number them 1 to 10 for levels of importance or critical of error. Next, features not to be tested. This is a listing of what is not to be tested from both the user's viewpoint and what the system does and a configuration management version control view. This is not a technical description of the software, but a user's view of the functions, such as identifying why the feature is not to be tested. There can be any number of reasons why you don't want to test something. Why not to be included in this release of the software? What is a low risk? It has been used before and is considered stable. Will it be released but not tested or documented as a functional part of the release of this version of the software? Sometimes features can be rolled out just as an alpha, beta, or just experimental feature that really they don't care if it breaks or doesn't break. It's just being rolled out to kind of see how the users use it. And it may not be important that if it breaks or not. It's just something that's experimental. We've seen this with like Google Labs where they put out some test features or applications that you can kind of play with. They're not live features. Yes, there could be buggy as hell, but they don't care. They just want to see if people are interested in using it. Next, we have our approach. This is your overall test strategy for this test plan. It should be appropriate to the level of the plan, the master, acceptance, etc., and should be in agreement with all higher and lower levels of the plan. Overall rules and processes should be identified. So here are some questions recommended by the IEEE standards to help you identify the appropriate testing approach. Are any special tools to be used, and what are they? Will the tool require special training? What matrix will be collected? What level is each matrix to be collected at? How is configure management to be handled? How many different configurations will be tested? What type of hardware is used? What type of software is used? What is the combination of hardware, software, and other vendor packages? What are the regression testing rules? How much will be done, and how much at each test level? Will regression testing be based on severity of defects detected? How will elements in the requirements and design that do not make sense or are untestable be processed? Is this a master test plan? The overall project testing approach and covering requirements must also be identified. Specify if there are any special requirements for the testing. Only the full component will be tested. A specific segment of grouping of features components must be tested together. Other information that may be useful in setting the approach are mean time between failures. Is this a valid measurement for tests involved, and is the data, if the data is available? Software reliability engineering. If this methodology is in use and if the information is available. How will meetings and other organizational processes be handled? Are there any significant constraints to be tested? Resource availability. What are your deadlines? And are there any recommended testing techniques that should be used? And if so, why? So all that needs to be put into the approach section of your testing plan. So next we have the items pass-fail criteria. So what are the completion criteria for this plan? This is a critical aspect of any test plan and should be appropriate to the level of the plan. The goal is to identify whether or not a test item has passed the test process. So at the unit test level, this could be items such as all test cases completed, a specific percentage of cases completed with a percentage containing a number of minor defects, code coverage tools indicating all code covered. At the master test plan level, this could be items such as all lower level plans completed, a specified number of plans completed without errors, and a percentage with minor defects. And then for either case or all the above, this could be an individual test case level criteria or unit level plan, or it can be general functionality requirements for a higher level plan. What is the number and severity of defects located? Is this in a specific section of code, or is it generally all over the place? Is it possible to compare this to the total number of defects? This may be impossible as some defects are never detected. A defect is something that may cause a failure and may be acceptable to leave in the application. A failure is the result of a defect as seen by the user and the system crashes, or the system's just not usable. Suspension criteria and resumption requirements. So this is kind of where you look when you're in the testing process, when do you need to stop testing and when do you need to restart testing? So know when to pause in a series of tests or possible terminate a set of tests. Once testing is suspended, how is it resumed and what are the potential impacts of, say, for example, your regression tests? If the number or types of defects reaches a point where the remaining test has no value, it makes no sense to continue the test. You're just wasting time and resources. So how do we determine this? So start by specifying what constitutes a stoppage for a test or series of tests and what is acceptable level of defects that will allow the testing process to pass the defect. Therefore, testing after a truly failure event or fatal event will generate conditions that may be identified as defects, but are in fact ghost errors caused by an earlier defect that were ignored. So if you keep testing after a particular test failed, you could potentially get additional failures based off of that an earlier test. So now you're getting some additional defects that really don't apply. It's just because the first test failed. Testing deliverables. So start by asking yourself, what is to be delivered as part of this plan? So your test plan, your test design specifications, test case specifications, test procedure specifications, test item transmitting reports, test logs, test increment reports, test summary reports, test incident reports. So test data can also be considered a deliverable, as well as possible test tools to aid in the testing process. So one thing that is not a test deliverable is the software that is listed under test item and is delivered by development. So you're not actually testing the deliverable of the software. So the software is deployed and then you're just testing the software once it's on the system to be tested. These items need to be identified in the overall project plan as deliverables or milestones and should have the appropriate resource assigned to them in the project tracking system. This will ensure that the test process has visibility within the overall project tracking process and that the tests it takes to create these deliverables are started at the appropriate time. Any dependencies between these deliverables and the related software deliverables should be identified. If the predecessor document is incomplete or unstable, the test products will suffer as well. So it's just real critical that you make sure that you have all the documents in place before you start building the test plan, or you could potentially be building test deliverables on something that is either not complete or not finished. Next, we have testing tasks. There should be tasks identified for each level or each test deliverable, including all inter-task dependencies, skill levels, and so on. These tasks should also have corresponding tasks and milestones in the overall project tracking tool, be it Jira, Bug Tracker, whatever. If this is a multi-phase process, or if the application is to be released in increments, there may be parts of the application that this plan does not address. These areas need to be identified to avoid any confusion should defects be reported back to those future functions. This will also allow the user and testers to avoid incomplete functions and prevent waste of resources chasing non-defects. If the project is being developed as a multi-party process, this plan may only cover a portion of the total functions and features. This needs to be identified so that those other areas have plans developed for them and to avoid wasting resource tracking defects that do not relate to this plan. Also, when dealing with a third party that is developing the software, this section may contain descriptions of those testing tasks belonging to both the internal group and the external group of the third party. So testing environments, are there any specific or special requirements or infrastructures required for this test plan? So such as special hardware, such as simulators, static generators, VMs, etc. How would this test data be provided? Are there special collection requirements or special ranges of data that must be provided? How much testing will be done on each component of a multi-part feature? Special power requirements, special versions of other supporting software. This is key if you're using things like Maven and that pull in third-party dependencies. You need to make sure those are all up to date and functional. Restricted use of systems during testing. A lot of companies don't do this, but you have a specific QA environment that hopefully you're testing all the code once it's been deployed and they're not doing constant deploys while you're testing. Tools, both purchased and created. This could be like SmartBear and some other testing tools. Communications, what should you have to test? Web, client servers, networks, topology, internal and external system, bridges and routers, and finally, security. Estimates. So in this section, you need to break down and provide a summary of test estimates, cost or efforts, and or provide a link to the detailed estimations. There are many elements to be considered for estimating the effort required for testing. It is critical that as much information as possible goes into the estimate as soon as possible in order to allow for accurate test planning. And you also need to make sure that you understand what needs to be tested, because sometimes test the functionality click of a button on the screen. You may look at that and say, oh, that's a quick 5-minute, 10-minute test, when in reality, that by clicking that button may have a larger impact on the back-end systems. That pushing of the button might turn the lights on or kick off another process. So you may have to dig a little bit deeper into what the task item is before you can actually estimate time to it. Poor estimation of times can result in poor scheduling later. Scheduling should be based on realistic and validated estimates. If the estimates for the development of the application are inaccurate, the entire project plan will slip, and the testing is part of the overall project plan. As we all know, the first area of a project plan to get cut when it comes to crunch time at the end of a project is the testing. It usually comes down to the decision, hey, let's put something out, even if it doesn't really work all that well. And as we all know, this is usually the worst possible decision. So this section needs to address the following questions. How is slippage in the schedule, or how slippage in the schedule will be handled should also be addressed here. If the user known in advance as slippage in the development will cause a slippage in the test and the overall delivery of the system, they just may be a little more tolerant if they know it's in their interest to get a better tested application. So if you have a hard deadline with the client, it may be worth going back to clients and say, hey, those last minute features you wanted need some additional testing, so we need to push out the release just maybe a week or two more. By spelling out the effects here, you have a chance to discuss them in advance of their actual occurrence. You might even get the user to agree to a few defects in advance if the schedule slips. At this point, all relevant milestones should be identified with their relationship to the development process identified. This will also help in identifying and tracking potential slippage in the schedule caused by the test process. It is always best to tie all test dates directly to the related development activity dates. This prevents the test team from being perceived as a cause of delay. For example, if a system testing is to begin after delivery of the final build, then system testing begins the day after delivery. If the delivery is late, system testing starts from the day of delivery, not on the specific date. Staffing and training needs. So this is another critical area that sometimes is overlooked. So you need to identify all critical training requirements and concerns. These are going to be the training on the product and training for any test tools to be used. A lot of times companies will hire QA testers or just pull tester people in to start testing an application or software without really considering the training that needs to be involved to actually educate the testers on what the application is, how it should work, what the perceived end user expectations are. Also, some of the testing tools that may be implemented. For example, if you use SmartBear, there might need to be some training involved as to how to use the SmartBear application to build test cases, to actually test web service calls. So these are things that need to be considered when you look at your staffing and training needs. Once you have your staff and training, then you need to start breaking down the responsibilities. Who is in charge? There should be a responsible person for each aspect of the testing and the test process. Each test task identified should also have a responsible person assigned. This includes all areas of the plan. So for example, setting risks, selecting features to be tested and not tested, setting overall strategy for this level of the plan, ensuring all required elements are in place for testing, providing for resolution of scheduling conflicts, especially if testing is done on the production system, who provides the required training, who makes the critical go, no-go decisions for items not covered in the testing plan, and then who delivers each item in test item section. If you don't identify this before you begin testing, once you get into the test plan, you could have a situation where, oh, I didn't know to test that. I thought so-and-so was going to test that. Or that particular test role is outside of my scope, so I didn't test that because that's not what I do. So you need to identify these responsibilities first so you don't get into a situation where people either don't test or certain test roles may fall through the gaps because people don't think it's their job. The risks. So what are the overall risks to the project with an emphasis on the testing process? Now, this isn't risks from the development. This is for the actual testing. So some of the things we can run into: lack of personal resources when testing is to begin, lack of availability of required hardware, software, data, or tools, late delivery of the software, hardware, or tools, delay in training on the application and or tools, changes to the original requirements or designs, specifically what will be done for various events. For example, requirement definitions will be completed by January 1st, say 2000, and if the requirement changes after that date, the following actions will be taken. The test schedule and deployment schedule will move out an appropriate number of days. This rarely occurs as most projects tend to have fixed delivery dates. The number of tests performed will be reduced. The number of acceptable defects will be increased. These two items could lower the overall quality of the delivered product. Resources will be added to the test team. The test team will work overtime. This could affect team morale. The scope of the plan may change. You may have some organizations of resource. This should be avoided if possible for obvious reasons. Or you could just quit, a rather extreme option to say the least. Now, management is usually reluctant to accept scenarios such as the one above. However, even though they have seen it happen in the past, the important thing to remember is that if you do nothing at all, this usually results in that the testing is cut back or made completely, neither of which should be an acceptable option. So you have to make sure that you consider these scenarios. You don't want to run into a situation where a lot of companies do, where they hire all the resources they need to develop the software, or they contract out to get the software developed, but they wait till the very last minute to get a team in place to actually test the software. That's a huge risk. So you need to make sure all that's identified now before you get to the phase of testing. Assumptions and dependencies. Sometimes this gets added, sometimes it doesn't, but in general, the assumptions that have been made during the preparation of this plan, some of the assumptions may be that we assume that, say this is a internal office application. So we assume that only company employees will be using this software, when in turn that assumption could be invalid. What might happen is this software might actually be currently being tested or used inside of an organization, but is actually being designed long-term to be used as a tool that could be sold to other companies used within their internal organizations. So you got to understand the assumptions in place. So when you test it, you're testing it at the end user's perspective. And dependencies could be things like, does this depend on other particular software? Are there third-party tools? What else is required or it's dependent upon these choices? Next, we have approvals. Who can approve the process as complete and allow the project to proceed to the next level, depending upon the level of the plan? Sign off. Who's going to sign off on the testing is done? So at the master test plan level, this may be all the involving parties. So it could be at all the different levels of the phase plans. When determining the approval process, keep in mind who is the audience. The audience for a unit test plan is different than that of an integration system or master level plan. The levels and types of knowledge at the various levels will be different as well. Programmers are very technical, but may not have a clear understanding of the overall business process driving the project. Users may have varying levels of business acumen and very little technical skills. So you need to ensure that who's approving this document, when you go to submit it for them for approval, that you actually talk to their level. So if you're dealing with programmers, you may have to get down into the weeds and be very technical. Whereas if you're talking to a BA, you may need to keep it a very high level conversation. Finally, what are some of the tips on writing a successful test plan? Well, make the plan concise. Avoid redundancy and excess. If you think you do not need a section that has been mentioned in the template above, go ahead and delete that section in your test plan. Be specific. If you specify an operating system as a property of the test environment, mention the operating system edition and version as well, not just the operating system name. If you say Linux, there are many different flavors of Linux. So if you're using Ubuntu, make sure you say Ubuntu 16 or CentOS 7. Make use of lists and tables wherever possible. Avoid lengthy paragraphs. Have the test plan reviewed a number of times prior to baselining it or sending it out for approval. Remember, the quality of your test plan speaks volumes about the quality of your testing you or your team is going to perform. And finally, remember, a good test plan is a guideline based on which test execution should be tracked. For successful testing and good product test delivery, it is important to update and make required changes in the plan as per changes in any other parameters which was based of the test plan. Like any type of documentation, just make sure you always keep this as up to date as possible. Make sure you do the revisions as properly and stay on top of this at all times. Every time you go through a new phase of development, you should be revisiting the test plan and updating the test plan accordingly. So let's jump out of here for a moment and take a look at two test plans that I found. So this first one here I found at softwaretestinghelp.com. So on your first page of the test plan, we want to include our test plan identifier. So our test plan identifier is going to be the name of our project or the application, maybe some additional details here. You want to give it the date, some contact information, or company information as well. Down here, you could also add versionings, when it was created, when it was last updated, if the status, if it's a draft, if it's final, and so forth. Here, they went in and they just jumped right into the revisions and sign-off sheets. So they skipped the introduction altogether. They went straight to references or approvals. So document history, here's your references or revisions, approval list, reference documents, and then all test plans should have a table of contents to go with it so that you can easily identify where particular features of your test plan, what pages they reside on. So as you can see here, they have introduction, test strategy, execution strategy, test management, and you can break it down into sub-levels like purpose, project overview, who's the audience. So you have the introduction, the purpose. This plan describes the testing approach and overall framework that will drive the testing of their software. brief overview of the project. Who is the audience? The project team members performing tasks specified in this document provide input and recommendations to the project managers, the stakeholders, technical team, and the BAs. They have a test strategy, so they list out some of their test objectives. Here's some test assumptions, key assumptions, production-like data required and will be available. And each test phase, cycle 3, will be indicated in the defect rate, so they should expect defect. Overall, some general assumptions, functional testing information, user acceptance testing, testing principles, data approaches, scope and level of testing. So you got your purpose, scope, testers, and method, testing team, scope, first level navigation, dealer and admin modules, timing at the beginning of each cycle, functional testing. So they break it down even further. Some other things you can add, like I mentioned before, you can add tables, you can actually add some charts, test deliverables, the test plan, test lead, who's the reviewer, who's basically in charge of each deliverable, your milestones, user acceptance testing, again, purpose testing. So you can break these down into each particular phase for each group or person that is testing. Test effort estimates. So this document lists, so they actually broke it out into a separate document. Execution strategy. So 100% test scripts executed. Test team, technical team, 95% pass rate, etc. So you kind of check off if they passed or failed. Validation. Here again, high, medium, low, critical, cosmetic, basically low impact, really not affecting the use of the application that could probably go out the door. Your testing matrix, this is critical. We talked about this a little bit in our test strategy plan. Your burn down, your test failures, pass versus fail. So you can kind of keep track of at a percentage how things are doing. You could actually even put in nice flowcharts. So how is the defect tracking to be reported? So start, tester, report defect, test lead, validate defect. Then it goes over to the development lead. It gets assigned out. And then this goes through your process. So if the defect is reported, when does it come back to the tester? When does it get approved? Or if it's not approved, how is it handled? Test management process. Here's our test management tools, our design process. So understanding requirements, establish traceable matrices, preparation of the test, and so forth. Test execution process, execution of each test step in the test case. Again, mark, pass, fail, raise defect. Again, we're getting back into this little chart at a more detailed level. Test risk and mitigation factors. So scheduling, testing schedule is tight. If the start of the testing is delayed due to testing, high. Testing team can't control the preparation tasks in advance, and early communication with involved parties. You got your defects, your scope, your resources, not enough resources on board too late, process taking around 15 days. This happens more often than you think. Role expectations. So here you can define your roles: project manager, test lead, business analyst. Then you assign who is the person that meets these roles, and then you give their contact information. So there's no confusion as to who should be going to who when they have questions at each particular level. And then here they break it down even further. So project manager, what are they doing? Reviews the content of the test plan, strategy sign off. Development team test environments. So here's the test environments that are going to be required. And then approval. So here's your sign off sheet. So this is one. If you notice, it was missing a couple different things, like the assumptions and dependencies. Some of the specific test items were left off. They were very generic. Features not to be tested was kind of left off. So here's another one. This one came from software testing class. So typically your project name, sample test plan, the draft version, who it was submitted by. So if you notice, this one here doesn't actually have the same version numbers like this broken out, but here your draft version is essentially going to be like the product version, the draft version, and then the revision version. So you can combine all that into the actual draft version, the versioning number. Document revision history. So here's all your different revisions. So you can have the draft, you can say draft 2, or signed off final version for version 1, 2, 3. But then you'd have another one for 1.2.4, 1.2.5, 2.1.0, and so forth. Typically, you start out with draft because you have to basically get a document in place, and then once it's in place, then you just pretty much follow the numbering. Again, table of contents, your introduction, your objectives, scope, functions to be tested, GUI, report, output data, report, set up locations, functions not to be tested, not other than mentioned above in 3.1. I hate that because that's really can be generic, and if these aren't clearly defined, that will send you down a rabbit hole you don't want to go down. Preparing test cases, QA will prepare test cases based on requirement specifications. This will cover all scenarios for requirements. This is good, but you need to make sure that within this document, it references the requirement specifications. If it does not, you're going to be digging around for the document. So make sure everyone's on the same page. If you say you're going to be building or preparing something off of a requirement or documentation, it needs to be referenced in the test plan. Creating test data will be created by QA specialists. Development test sites based on scenarios and test cases. Process to be followed when sufficient time is not available. So they went ahead and they created a plan in case development runs over and they don't have enough time to test. So now they've kind of shorthand what they're going to be doing. Data creation, bug life cycles. Again, you can put in another chart. So unconfirmed bug, dropped in new, it gets assigned to someone. And then once it's assigned, ownership goes back, or it can be resolved. It then gets retested, reopened, verified, reopened, or closed. So this is, if you're using any type of project management system like Jira, this is kind of pre-built in, or you can build this workflow into your tool. So then all you have to do is say, hey, new defect, they assign it, it gets assigned to a developer, they resolve it, it goes back to QA to be verified. Once it's verified, it either gets reopened and back to development, or it can be closed, or go all the way back up to unconfirmed that they couldn't duplicate it. So this is kind of your workflow that would be incorporated into your project management tools. Talking about your test strategy, your black box testing, white box testing, performance testing. So again, if you have other phase plans, your performance testing could be essentially referencing another test plan. You really don't want to put too many of these into a single phase plan, but if you're dealing with a master plan, then just list all these in the master plan, and then you'll jump out to the individual documents as you need to test them. Alpha testing, test environments, test schedule, phase plan, design phase, code completion, code complete function, feature complete. There's a huge difference between these two, and a lot of companies and development teams don't follow that. So code completion function really is at the start. So if you're on, say, a 3-week sprint, so your first 2 weeks are development, then you have what is called code completion. So the sign-off would be from development to QA would be at the end of the second week. The third week would be QA, would be tested. You would have like 4 days for testing, get all the bugs identified and fixed. So then on Thursday would be kind of the feature complete, and then regression testing would run through on the Friday. And if everything worked, you would do beta ready, get out for delivery, deploy, or ship it. Bug review meetings, these are important, but you need to make sure you stay on task. Change requests, make sure you identify the process for requesting changes. And based on the level of the change or the level of the defect, how critical it should be to the next release cycle, or if it needs to go into the current release cycle. Defect reporting, so like if you're using Bugzilla, Jira, any project management tool, make sure it gets logged correctly into the tool. Again, list roles and responsibility, who does what are your deliverables, suspension of criteria, resumption of criteria, exit criteria, your level of risk, any acronyms. So at the end, if you had any abbreviations you used, it would be nice to maybe add a section where you actually kind of list them out. And if you notice, this one doesn't actually have an approval sign-off. So maybe they don't require it. But it is a good idea to make sure that you have some type of sign-off at the bottom of your document so that you know before it goes live or before you begin testing on this, that this has been signed off, everyone agrees to this, so that there's no questions or in communication when this goes out. So you get to the end of the cycle and people look at the document and say, well, this doesn't meet the requirements, or this requirements document doesn't match what was given to us. Why? Who signed off on this and why are we testing it? That's why this is critical. So to recap, what is a test plan? Well, a test plan is the overall document describing the scope, approach, and resources and scheduling intended for your test activities. The difference between a test plan and a test strategy is the plan is a individual testing process, integrated testing, unit testing, and your test strategy is the overall testing strategy for the entire coverage of the features to be tested, like the guidelines for the test approach to be followed, the order to achieve, the test objectives, and things of that nature. We walk through how to build a good test plan, all the different components that go into a test plan, and we reviewed some of the tips of writing a successful test plan. Does anyone have any questions?
Hey there, Michael. I was going to ask, let me start by saying this reminded me a lot of a DR plan. And I can imagine a non-technical manager understanding the necessity for a disaster recovery plan. In the same sense, though, that non-technical manager may not understand why we need a test plan, a testing plan. How would you go about trying to explain to this non-technical manager why this is a necessity?
Well, it's kind of interesting. So the easiest way I would try to explain this to someone that either doesn't understand the test plan or the reasoning for doing them is I would almost take that risk section that I went over, because the things that you're going to run into is, what are, some of the risks? Well, late deliveries of software because of bugs, delay in training of an application. Features that aren't tested, you're going to be putting out potentially buggy software. So in point, one of the companies I worked at in the past, we had no QA. The developers were doing the QA. And so you can understand the potential for failure there is you have a BA that takes the requirements, the BA hands it off to the development, and then development basically codes it, then tests it based on their understanding of the BA rules, and then the software went out the door. Well, developers are not end users. So if you are actually not going to test it, or you're not going to put a test plan together, you're missing that end user viewpoint of looking at the software before it goes out the door. So having a test plan really identifies and nails down what it is that the user should see and what the application should be doing in respect to that.
Good, I like that. Thank you.
Hey, Michael. I was going to ask you, should the test plan, like, for instance, as a QA, usually you have this tendency whereby you think, okay, the code has been frozen and you're ready to test. And all of a sudden, the developers keep creating new functionality into the code. Should the test plan also include, like, the code freeze date, whereby you don't expect new code to come in unless it's maybe bugs retest or something like that?
Yes, and in fact, I think one of these actually showed a good example. Yeah, here we are. So this section here, so code complete, functionality, feature complete, and regression test. So in this situation, so what you have is you have the sprint cycle where the developers are still coding. They're trying to get in as many defects or new features into an application as possible. That's their window. That is the code complete functionality window. They have that period of time to get everything done. Now, during that time, you could do some white box testing where you're testing things that are still in development. Code complete infrastructure design phase. So you have the planning, the design, it then goes to the coders, and then you have what is called code complete. It's not feature complete because potentially there are still some features that they may not have all the information for, or they've coded them and they're like, well, code complete meaning, all right, we've coded it to our understanding of the BA's requirements or the customer's requirements. However, we're not 100% sure that that's actually what they want. So let's get it to code complete. Let's give it to QA. Let QA view it from a user's perspective. And if it's not right, they'll kick it back as a defect. So you have that first window of just getting the code being done. Then it gets to QA. QA has a period of time to go through the code completed phase and go through creating defects and back and forth till they think the code is stable. At that point, it then becomes feature complete. And that feature complete is then when you start running all your regression testing systems against it to make sure that all the pre-known tests and bugs all still pass. Does that make sense?
Yeah, it does.
Any other questions?
So how flexible should this, this is probably throwing, how flexible should this be, like the code freeze? Can you be more flexible, let me say, as a developer, whereby, okay, maybe you fail to push everything in those 2 weeks, and maybe you got to push it to QC in the next week? Should it be concrete?
Well, you should have code freezes. Now, it may have been back on the other one. One of these actually handled if you don't meet your code freeze. So what you essentially need to do is you need to identify, and this is where this document really stands out. But what you can do is, if you know you're going to be able to test everything, so you have a week. So you basically set it up, okay, if we have our window, if the code gets to us on time, we have X amount of time to test, and these are all the things we need to test and will test. If that slips, and you can't slip the delivery time, you need to then have a secondary test plan in place of what you will forego in testing and what is acceptable not to test, or basically what is the acceptable risk that the company is willing to take, and then you build a test plan for that for the shortened test period. Thank you. We know your time is important, and if you would like to discuss any additional questions or comments you have, you can check us out on info@developer.com. You can check us out on developer.com/contact us. We're on Twitter @developer, and we're also on facebook.com @developer. Our goal is making every developer better, so please check us out, ask us questions, and check out some of our other videos.